Now I can hit record, so now it knows who I am. That's good. Okay, so let me send a quick email out to Jeff and Ann Briggs and see if I can get them to come over to this one. Oh, technology is so much fun.
And it does say at the top of mine, recording.
Oh, good. So if you don't see that one of these days, you'll have to remind me. Hey.
Okay.
You sure you're recording? Okay, hold on. This is why I'm missing my two screens, because I copy and pasting stuff from one place to the other.
Yeah, you get used to that pretty fast, don't you?
You do. Okay. Okay, so hopefully we'll see them come over and visit us here in a second. And I'm recording now, so we're actually going to start. So this time, open the power, share the screen, then open the PowerPoint. We're going to have her. You guys are doing great. You're here. You're all on. It's me that's a mess.
That's all right. None of us are perfect.
Okay, here we go. We're sharing screen. This is all new stuff for all of us. So, and from the beginning, okay, we're set and going here. So tonight, or last time that we met, and when you guys get the YouTube recording, you'll be able to see that. We talked all about the physical properties of soil. So tonight we're going to focus on the chemical properties. So nutrients, pH, fertilizers. We're going to walk through an example soil test so you can see the information a soil test would provide you. We are going to do soil tests. If you are a paid member of the class, you get one free soil test. We are going to send them back east to Harris Labs, and so they'll be $15 a piece for any additional tests, or for those of you that aren't taking this as a paid class or kind of auditing the class, you'll have that option as well. So we'll select those at our next meeting time. So I think some of you didn't get all the flyers and all the information, but the next time we meet is March 9th, if you're part of my Jim County class. And then we're meeting February 24th, which is a Saturday, if you're my two Weiser students. So I'm actually kind of like having the two Weiser students, because I get to trial all the things that I do with my big class ahead of time, so I can be sure that they work. Okay, so let's start on this. So first we're going to talk about high pH soils. Almost all of our soils in southern Idaho are considered high pH. If you go into northern Idaho, then you're starting to get some forest soils that have a little bit lower pH. And they use several different words, and you may have heard these to describe high pH. So alkaline, sweet. As much as I can figure out, sweet comes from the acid stuff is sour, so then alkalinity would be sweet. In reality, it's actually bitter, but that sounds a little different. Calcareous, so the reason that our soils have a high pH is because they have a high calcium content in the soil, so that's where calcareous comes from. Or high lime, so lime is a form of calcium, and so they might use that phrase. So soil pH neutral would be 7. And a lot of plants like to be right there at 7. Nature kind of likes to be in the middle of that soil pH range. And soil pH is actually a log-based scale. So that means if you go from pH 7 to pH 8, that's actually 10 times the alkalinity. And if you go from 7 to 9, that's 100 times alkalinity. So as you move out from that 7, things change pretty quickly. It's kind of like the earthquake scale kind of works in that same way. So there's some plants that really like our alkaline soil. So lilacs, peonies, sage, cherries, and plums, clematis, and sedum, all don't mind being in above 7. And there's some plants that just really don't care to be in our pH range. So blueberries, rhododendrons, azaleas, a lot of our pine trees, and blackberries would prefer to be under 7. Now, we really don't run into a whole lot of limitations in our soil until you get up into that 8.5, 9 range. And then you'll start to have some issues with high pH. And I've seen some of those soils. I want to say it's in between Payette and Emmett. There's some soils that are in that high pH range that I've seen up to 9. But most of my Master Gardener soils are in between 7.5 and 8.5. So here's a soil pH map of the U.S. So your blue would be your alkaline soils, and your red and pink are your acidic soils, and then your tan are more of your neutrals. So one of the problems is when you're getting a gardening vice or a gardening magazine, a lot of the places that do a lot of horticulture are Western Washington and Western Oregon, which is bright pink, and then in the Northeast. And so a lot of the general guidelines that they give don't work for us because they have completely different soils than we do. So when I go looking for information for plants, I kind of like to use Utah or Colorado. Nevada is not too bad because they have very similar soils to what we have, and so they give better information. And our stores aren't very good about this. You can go buy lime at the store and they will sell it to you. And that's pretty much the last thing that our soils need. So that's something you have to watch out for. So that kind of explains why that maybe you'll see that advice to lime your soils very often in gardening books. And it's just because they're written for areas that are not ours. So soil nutrients. So plants get all of their energy from the sun. Unlike us, we have to eat food to get energy. But we also eat food not just for the calories, but for the nutrients. So the plants also need nutrients. And so they get their energy from the sun, but they still need the building blocks of life from the soil. So they need nitrogen, phosphorus, and potassium are the 3 main nutrients that a plant needs. And those are usually abbreviated N, P, and K. Potassium sometimes is referred to as potash. So if you hear them talking about potash, and that's because when you burn plant material, it actually concentrates the potassium. So a really good source of potassium in the past is from ash. So that's how that name came about. Now we have to go back to like Latin and figure out why the abbreviation for potassium is a K, and we're not going to go there. You just have to memorize that one. We actually, as humans, need nitrogen. So nitrogen is a huge component of protein. So most of the amino acids have a majority of nitrogen in them. So we have that same requirement. We don't need phosphorus and potassium in the levels that the plants have, but plants happen to be a really good source of phosphorus and potassium. So kind of the secondary nutrients, so these main primary ones, if you're short of those, the plant's are really going to suffer. Some of the secondary ones are calcium, magnesium, and sulfur. And then you have your list of micronutrients, which are needed in little tiny amounts. And some of these are actually poisonous and harmful to the plants if they're over that little tiny amount. So a little is good and too much is bad on the micronutrients. So those include copper, iron, zinc, cobalt, boron, molybdenum, manganese, zinc, and chlorine. So those are all the things that make up a plant. And they're looking to get these from the soils. So this is often an illustration that's talked about when you're talking about yield or growth of a plant. So this is a barrel, and your lowest slat is as high as the yield is going to go. So in this case, the nitrogen deficiency is what's going to be holding that plant back. So it could have plenty of water and plenty of light and warmth, and it's got oxygen and everything else it's needs, but it needs just a little bit more nitrogen to bump up that yield. And we see this a lot. We tend to have low organic matter soils. We tend to be short on nitrogen, and that's a main plant nutrient. So usually most of our plants will respond really well to nitrogen. But if another one of these things is missing, so maybe you give your plant plenty of nitrogen, but it doesn't have enough water, you can see that would be the little slat that's down lower and is going to be holding you back. So just like humans kind of need all of those essential nutrients, or you have illness or deficiencies, plants kind of work that same way. So let's talk about nitrogen. Nitrogen is a really complicated cycle compared to the other nutrients. And that's because the air that we breathe is the majority of it is nitrogen. So there is a lot of nitrogen available in the air, but plants need it to be in the soil. So we have some plants that are nitrogen fixing. So that means they can use the nitrogen in the air and put it into the soil. And it's not actually the plant that's able to do that. It's the bacteria that are in combination with the plant. So there's nitrogen-fixing bacteria. They like to live in legume roots and nodules, and they help that plant take in nitrogen. So legumes would be things like peas, clover, that are able to use nitrogen out of the air. And they can be used as green manures and cover crops, because if you turn in that plant, you're adding nitrogen to the soil. So then if we go down, there's nitrogen-fixing soil bacteria that naturally take in. But then we have these processes that change the type of nitrogen. So there's ammonium nitrogen, nitrite nitrogen, and nitrate nitrogen. And this is always changing in the soil, and it depends on temperature and moisture level. If it's pretty dry and warm, things kind of stay on the ammonium side. And if things get really wet and cold, it tends to go over to the nitrite and nitrate side. And then if you till the soil, if you're turning up the soil, then a lot of that soil that's near the surface, some of it is going to gas off into atmospheric nitrogen. So you can actually lose the nitrogen out of the soil back into the air for denitrifying bacteria. And so this is one of the reasons that compost is not so great or so high in nitrogen, because the bacteria are breaking it down and you're turning it all the time to get that to go. But it does release quite a bit of its nitrogen into the atmosphere as it's breaking down. So it still retains a little bit of it, but that's where some of it's going. Good sources of nitrogen, animal manure. Actually decomposed animals, all that organic matter that gets decomposed puts nitrogen back into the soil. So kind of the circle of life. So when you're adding nitrogen on, you have to be a little bit careful about having it either leach down through the water profile. Nitrogen is very water soluble. So let's say you put a ton of nitrogen on your lawn and then you accidentally leave the sprinklers on for 24 hours. You've got a sandy soil. All that nitrogen will be underneath the root system of your plants and lost down to groundwater. I actually had a gentleman, he used ammonium sulfate on his lawn and didn't read, actually he went and bought a farm bag that didn't have very good label instructions on it. So he had watered his lawn and then put this on top at probably 5-10 times the rate he should have. And then it was August. And so the ammonium sulfite, so the nitrogen burned, but also the sulfite turned to sulfuric acid, and he fried his lawn. It took me the longest time to figure out what he did, because he lives in town and there was these straight lines on both sides of his property, and his lawn looked like sawdust. He just burned it to the ground. So got to be a little careful with your nitrogen fertilizer if you're doing things. Okay. So we also have a huge issue with nitrogen groundwater pollution. Weiser is actually in a nitrate concern area. We've actually had to turn off the city wells that we're using groundwater, and all of our drinking water has to come out of river water, surface water, and be treated because our nitrate is so high in our groundwater. I found out since I've been researching this that that's actually happened to several municipalities in our area. So I believe Fruitland has the same issues, as they've had to switch over water. And that's very expensive for the citizens of those towns to have to treat river water to get it up to drinking water standards. But they haven't found a way to take that nitrate out of groundwater efficiently. So nitrate level is 10 milligrams per liter. One of their main concerns is that nitrate will replace your hemoglobin in your blood for the oxygen. So it's for people that are sick or elderly or infants, that nitrate is actually blocking the oxygen. So it causes a syndrome called blue baby syndrome, and it's the infants are not getting enough oxygen because of the nitrates in their water. So some pretty serious stuff. And I figure the sources of nitrate are your fertilizers, your manure, wastewater applications, septic systems, decaying organic matter, and then if you're in an area that has a any of these things that have gotten buried in the past, it could actually kind of be a natural source. So if you're in a more tropical area, you can have some natural sources of nitrate from that plant material breaking down. But mostly ours is over application of fertilizers, and then we have a underground kind of an aquifer type system, so it's kind of a closed bowl in there. So if you put too much nitrate in, it goes beneath the plant roots, and there's really no place for it to go. It doesn't keep draining down through the profile, it just sits in there. So without having plants to be able to take that up, it's really hard to remedy that. So we do have to be careful with our nitrogen fertilizers. They used to always, it was just the farmer's fault, and the more they start to research, urban areas are really bad about over applying fertilizers to their lawns and parks. So this can be an urban issue as well. So role of nitrogen in plants, there's basically nothing the nitrogen doesn't do in a plant. So that's why it's such a huge nutrient. So it's part of all the living cells, necessary part of all proteins, enzymes, and metabolic processes, involved in the synthesis and transfer of energy. It's part of chlorophyll, so the green pigment that's responsible for photosynthesis. It helps plants with rapid growth, increasing seed and fruit production, and improving the quality of leaf and forage crops. Often comes from fertilizer application and from the air. So legumes can get their nitrogen from air. So there's a lot of things a plant needs nitrogen for. So the next slide talks about nitrogen deficiency symptoms, what that would look like. So stunted growth, shorter internodes, so that's the distance between the kind of the joints on a plant. And you get small, pale yellow leaves. Plant might be a little light green. So Diane was worried about her lime plant. Usually a nursery type plant will have plenty of fertilizer in the potting soil. So sometimes it can be hard to tell nitrogen deficiency syndromes because this is kind of your general, the plant's not doing well symptoms. Older leaves are generally affected first with nitrogen. It'll actually take the nitrogen out of the older leaves to support the new growth. Reds and purples can intensify in plants that have nitrogen deficiencies. Flowers will bloom heavily, but they may be delayed. So you'll see fertilizers that are like growth fertilizers and then bloom fertilizers. So the bloom ones are usually heavy in phosphorus and low in nitrogen. Fruits that can be light without nitrogen, and the fruits can be highly colored, early to mature, and small. And I don't think I've ever had something come into plant clinic where I went, ooh, that's nitrogen deficiency. It's one of those ones that the plant kind of has a failure to thrive all over, and it can be difficult to find out without actually taking leaf samples and having those tested. So here's some examples of what nitrogen deficiency would look like. So the picture in the corner there is corn, and it's got some pretty bright yellow streaking and some stunted growth. The strawberries just have some red and purple coloring to them. There's other diseases and issues that can cause that same thing in strawberries. And then the rhododendron there. This one I think would be an easier one to tell because the newer leaves are still bright green. It's all the older leaves that have gotten that yellow color. And that, this would be a little bit harder to tell from iron chlorosis, but generally in nitrogen deficiency, iron chlorosis, your veins are going to stay green, and in nitrogen deficiency, they wouldn't. So that's kind of the telltale sign there. So phosphorus has a much easier cycle. It's much more stable than nitrogen is. So basically, you're getting phosphorus from dead plants and manures and animals to put it into solution. So one problem is phosphorus can be unavailable to plants. So you can have high phosphorus in the soil, but the plants can't get it until it's in a water solution. So not all phosphorus versions are go into solution easy. They tend to stay as rock. Phosphorus can leach, and that's usually not a main way of getting rid of phosphorus. Erosion in runoff is probably going to be your biggest issue with phosphorus. It really likes to hold on to that soil. So when you lose soil off your landscape, the phosphorus tends to go with. So phosphorus is a super limiting nutrient. If you remember the barrel, in any water-based system. So if you're getting algae blooms or other water quality issues, that's almost always caused by phosphorus. So water-based plants are very low in phosphorus, and any addition to it causes huge growth. So instead of nitrogen being the issue for water quality, it's phosphorus in that case. So we naturally have pretty high levels of phosphorus in our soils, and soil tests usually show that. Every now and then, people will need to apply phosphorus, but mostly a lot of the soil tests I see coming back is nitrogen is really their only need. Oops, I think I went too far. Let's see if it'll back up. So this was talking about phosphorus in surface water. I forgot I had a slide that explained all that. So erosion and surface runoff allow P to enter the system. It does a thing called eutrophication. So you actually don't want plants to grow uncontrollably in surface water. And that's what happens is they get a little bit of that phosphorus and they get all excited about it and bloom. But unfortunately, they shade each other out and they get older and then they die in the water. And as they're dying and breaking down, they use up all the oxygen and then there's no oxygen left for fish. So it's that's kind of a hard thing to think of because when you think of photosynthesis, you've got all these plants and they're producing oxygen. So why is eutrophication a problem? It's actually when the plants die and the bacteria that break them down, it uses the oxygen up in the waters. So phosphorus in plants, essential part of photosynthesis, involved in the formation of oils, sugars, and starches, helps with the transformation of solar energy into chemical energy, proper plant maturation, and withstanding stress. I need to not put big words in my PowerPoints for late in the afternoon because they're harder to pronounce. Phosphorus will affect rapid growth. It does encourage blooming and root growth. So sometimes you'll see things like a root tone or things that are meant to help establish roots in plants. Often there's a hormone in there, but usually there's a little bit of phosphorus too. It really gets the plants established well.
Lay down.
Phosphorus deficiency symptoms, they'll get a red or a purplish color. So if you've ever overwatered your tomato seedlings when they were little, mine usually end up with purple color on the backs of the leaves, and that's known to be a little bit of phosphorus deficiency. That's mainly from me mistreating them by having them being too wet and cold for too long. Death of tissue or necrosis can follow that. If you don't have enough phosphorus, you're going to have poor root growth. The lower stems may be purplish, and the plants may exhibit stunting and delayed maturity. They might lose their lower leaves and may exhibit reduced flowering because phosphorus is a big part of flowering. So here's what phosphorus deficiency symptoms look like. So once again, corn. Corn is such a fast-growing plant that if it's missing anything, it tends to show it very quickly. Any plant that's going to get 7-8 feet tall in one season and that kind of growth rate is going to have issues if it doesn't have all the building blocks. And then here's kind of that purple cast I was talking about on the back of the tomato leaves. And it kind of depends on what type of potting soil you're using too. So if I don't get mine potted up from like the Jiffy sterile mix into some sort of potting soil that has some nutrients in it, that can make this purple a little bit worse. They tend to pull right out of it, but I'm sure it stunts them a little bit having that purple coloring. So next up is potassium. We have really, really high potassium concentrations in almost every soil sample I've seen from this area. So our soils tend to be really high in it. It's not always available. Some plants will luxury uptake potassium. So there's a certain level they need, but if there's extra there, they'll go ahead and take it up. And we actually have huge issues with this with alfalfa. Alfalfa is a luxury uptake of potassium. So then when our dairy cows eat this high potassium feed, it actually throws off their calcium balance. So when they have a calf and start producing all this milk, it actually takes the calcium out of their blood, and they go a little kooky. So they will spin around in circles and lay down and think they're dying, and my husband has to go get them an IV bottle of calcium and put it in their vein, and then they pop right back up. So it's an issue that usually is only done with milk or lactating animals, but we've actually occasionally sourced hay from out of this area that is a lower potassium hay to feed to them while they're dry, just so we don't have this issue. But I'd say a majority of our cows have to have some intake of calcium to prevent this. So an issue in the dairy industry. I guess good for us unless you're not supposed to be having high potassium greens. I think it does play with some blood clot medication that you have to watch how much potassium you're getting. Spinach tends to be really high in potassium, which makes me think that it's probably a luxury uptaker as well. Mm-hmm. So potassium doesn't do a lot of moving and shaking. As you can see, most of those little arrows have very slow on top of them. So it's in minerals and feldspars and micas. It's in crystals and clay. And then out of all the potassium out there, like 0.1, 0.2% is actually in soil solution. So this is where soil tests are kind of hard, because we'll get really high potassium soil tests, and they try to mimic what a plant can do when they're testing soils. But I think they probably overestimate potassium a little bit. I think it comes out of the soil a little bit easier with their soil testing methods than sometimes nature can do. But I don't think we will ever have to worry about a potassium deficiency in our soil. We just tend to have a lot. In fact, the numbers for supplying potassium fertilizer, like anything that tests like under 350 parts per million, and most of our soil tests come with 3,000 parts per million in the soil. So it's got a lot there to work with. So potassium is absorbed by plants in larger amounts than any other mineral element except nitrogen. Helps in the building of protein, photosynthesis, fruit quality, reduction of disease. And it's supplied by plants by soil minerals, organic materials, and fertilizer. So this is one where they're getting the majority of it just from the minerals in the soil. And then the organic materials and fertilizer are just an addition. Potassium deficiency is going to show up as a bronzing and dying of the leaf margin, which the dying of the leaf margin is most often in our area a leaf scorch symptom, so not a potassium deficiency. Some spotting between veins, chlorotic with brown spots throughout the leaf, tendency to wilt easily, stunted internodes and roots, less flower buds, and fruit is small and poorly colored with potassium deficiency. So here's some examples of what potassium deficiency would look like. So a little bit that, one leaf on the bottom there looks a little bit like iron chlorosis, but you're getting yellow clear around the leaf margins and some of that necrotic dead. In that tomato, you can kind of see the bronzing that they're talking about. So this is another thing. If you're growing in a potting soil and versus our standard soil, you can be low on potassium. So that potting soil, could be potassium deficient, where our native soil is probably never going to be. And then once again, that's what it looks like in corn. It seems like you can see every deficiency possible in corn. It's kind of a pain. So here's looking at some of the other ones. With our high pH soil, there's certain micronutrients that just aren't available. So if we look at like 8 down that pH range there, nitrogen's going to be fine. We have a little reduction in phosphorus. Potassium, sulfur, calcium, magnesium are all fine. But look at iron. So iron at a range 8, you've got a half or a quarter of the iron that's available at a lower range. So that's why we see a lot of iron chlorosis, is because of our high pH. Manganese also has some of the same issues. And that's not one that manganese can be difficult to supplement in. It doesn't come in a fertilizer form very often. So this is where just organic matter is your best choice to hope to pick up some of that. Boron has kind of an interesting curve there, that it becomes really unavailable at 8.5 and then more available again at 9. So it has some interesting chemistry there. Copper and zinc we can be just a little bit low in, and molybdenum we shouldn't have any issues. So deficiencies in micronutrients are the iron, the manganese, the boron, the copper, and the zinc. So those are ones we have to watch for. And they can be difficult to apply because they're needed in little tiny amounts. So it's pretty easy to get chelated iron granules to apply to plants, and that's recommended if you see that iron chlorosis. But the magnesium, boron, copper, and zinc, you have to go to a more of a specialty place and have them mixed up. And usually it's a foliar spray that you're going to put on versus something that you put down in the soil if you're going to try to correct those deficiencies. Calcium deficiency. So we see blossom end rot in tomato and pepper. I've even seen it in squash. So we have very high calcium soils. So how do we still have tomatoes that have a calcium deficiency? So this is actually brought on by cold temperatures or excessive heat during when the blossoms are setting and fluctuations in the water supply. So we've got lots of calcium in our soil, but it has to be in solution and it has to be able to get to all parts of the plant. So if your plant is slowed down its growth rate due to the cold or the heat, or you've had lots of water and then not enough water, it's more likely to have these blossom end rot. They do have a foliar spray with calcium in it that can help. I find that usually Roma tomatoes are the worst, so that's just a tomato variety issue. But usually it's just those first couple ones in the spring, and then the rest of them, straighten out, and you won't have as many later on in the season. But you'll have people tell you that you need to put eggshells on and you need to add calcium to your soil. But as we talked before, we have very high calcium soil, so it's not that it's not there. The plant just is having trouble moving it around. Iron chlorosis. So chlorosis means lack of chlorophyll, and iron chlorosis is lack of iron causing this issue. Causes the leaf to become yellow, but the veins in the leaf stay bright green. And the newest leaves on the ends of branches are the most affected. So if you thought about nitrogen deficiency, it was the old leaves that were affected. Iron chlorosis, it's the new leaves that are affected. And actually, this has turned me away from, they have all sorts of plants now that they've made in a beautiful yellow color, and I just think they look sick. So I can't enjoy any yellow plants because they look like they have iron chlorosis. They don't look well to me. So this can actually happen in your lawn too. So turf grass actually has a pretty high iron requirement. So if you're getting yellowing in your lawn, and the hard part is you see that yellowing, and some people think, oh, I'm not putting enough water on. I need to put more water on. Well, that actually leaches even more of the iron out, and you make the problem a little bit worse. So that's one you kind of have to diagnose as iron chlorosis versus drought stress. So importance of soil testing. I think the hard part is people come to me to have a soil test with some weird general things like nothing in my garden grows right, I'm going to do a soil test. Or I think I have pesticides in my soil, so I'm going to do a soils test. And those things sometimes the soil test isn't going to help you out on those. But there's a few things soil tests are really good for. So saving money on fertilizer. If you do a soil test and you don't need to add phosphorus or potassium, then you can just buy nitrogen fertilizer and not have to worry about the other two. You can prevent entire environmental contamination from not applying too much of these nutrients. Your crops and your landscape plants will be very productive. You can be aware of nutrient deficiencies that you might have, so you can watch for those symptoms or look up what those symptoms may look like in your plants so you're ready to treat them. And healthy plants tend to be more drought tolerant, a little more winter hardy, and pest tolerant. So you can save yourself some other problems if you're properly fertilizing your plants. So our local lab that most of our soil tests go to are Western Laboratories. They're based there in Parma, and they offer a garden soil test, and it is $46. So you have to be fairly serious about what you want to do there. That test will do pH, texture, soluble salts, cation exchange capacity, and we'll talk about what some of these factors mean. Percent lime, percent organic matter, nitrates, ammonium, phosphorus, Calcium, magnesium, sodium, zinc, iron, manganese, copper, sulfates, and boron. So all your macro and micronutrients. So I said this one's $46. We get a little bit of a university educational discount if we put a bunch of samples together and send them off as a research project. And we can get that down to the $15 level, which is a pretty good savings. So we'll get you more information about that as we get closer to our March 9th date and tell you how to sample and how much soil to bring. But if you're not part of Master Gardeners or on an off season, this is our local choice for a soils lab. U of I does do soil testing on a limited level, but they're at the same cost plus shipping. So that makes it not a more economical choice, and they're a little bit slower. So usually Western labs will have results back to you in that 24 to 36 hour time period. So they're pretty fast, even though they're a little expensive. So proper sampling techniques. You're going to want to use proper sampling tools. So you can use a soil probe. I found that soil needs to be at the perfect moisture to get that soil probe to go down in the soil without a lot of cussing and jumping up and down on top of it. So if you have it perfectly moist, you can take a nice 12-inch core, and sometimes you can't get the tip even to go into the ground. One thing you want to watch out for is rust on your tools, because if you have a very rusty tool that you take your sample with, your iron is going to be higher than it should be. You're going to take a lot of smaller samples and combine them into one sample. And you kind of want to go by areas that are being treated the same. So avoid unusual areas. This comes from a large farm. So divide fields into areas for sampling, and I think they're talking acres here. But let's say you wanted to do your lawn. You'd want to pick several areas in your lawn to do that sample that would be representative of the whole. If you have like raised garden beds, a lawn, and then a fruit orchard, those are all getting managed very differently. You probably want to do 3 different samples to actually have information that's useful to you. You want to mix that composite sample well in the bucket so that all the different areas are blended nicely, and then number and record the samples. So I've had trouble in the past that people have brought me 2 samples and they forgot to label them, and they're like, I don't remember if this one's for my lawn or for my raised beds, and then we have to try to guess when we get the results back and guess which one is which. So labeling is always important too. Okay, so we're going to walk through a soil test, and this happens to be the printout from Harris Labs, the one we're going to use. And we're going to just kind of talk about what things mean as we walk through this report. So the first things it gives us is pH of the soil, and this one was a 7.8, so moderately basic. So 7 is in the middle, so we're just a little bit to the right of being even there at the 7. Soluble salts is 0.40, which they're calling normal. They'd like to see that number to be less than 1.5. If you have a soil that's high in soluble salts, it generally is from too much animal manure. Animals, especially animals in confined feeding operations, have a fairly high salt diet, and that can make their manure higher in salt. So if you're seeing high soluble salts, you might need to switch over to a mushroom compost or a forest-based compost for a little while to bring that salt level down. Percent lime, this one just says moderate. It doesn't give you a number, but they're wanting to see between 3.1 to 5.5% lime. If this lime number is really high, that means you're not going to be able to change the pH of your soil in any appreciable way. So it's like having a lot of Tums in there. You know, no matter how much more acid you put in, it just keeps neutralizing it. Percent organic matter is 1.75, and that is low according to their test. That's probably about average for what we see in our area. You have to work a little bit on organic matter in Idaho. There's the nitrates and the ammonium. So when we're talking total nitrogen, we would add those two. So it'd be 20 plus 3. And if you remember from the nitrogen cycle, it kind of switches over from nitrates nitrite to ammonium. So those numbers kind of shift within that. But plants can use both of those for nitrogen. So adequate, it was showing 10 to 35, and that the ammonium is a little bit low. They'd like to see 5 plus. So overall, depending on what you want to grow, this soil is probably a little low in nitrogen. Shows phosphorus at 15, which would be low. They're looking for 25 to 40. And then you see phosphorus parts per million in Bray. So there's an Olson phosphorus test, and that's for high pH soils. And the Bray phosphorus test is for low pH soils. So usually you'll only get numbers from one or the other, and the lab will choose which one's appropriate to do on your soil. Okay, so here we go. Potassium is 280 in this one, so they're saying it should be 300 plus. Potassium bicarb, so that's just a different type of test that they're doing that takes into effect the percentage of lime or bicarbonate that you have in your soil. We have sulfates at 20, which shows adequate. It has calcium at 3,500, which is showing as high. Magnesium at 150, which is low. Sodium at 210, which is okay, but getting to that edge of 225. But it showed that it wasn't very high in soluble salts, or it was still okay in soluble salts. Zinc is at 2, copper at 1, manganese at 6, iron at 18, and boron at 0.8. So almost all the places you're going to get a soil test from are going to give you this interpretation or what it should be and kind of the range or what numbers you're looking for. So kind of like reading a human blood test that, you know, they make the little high marks next to your cholesterol or your other issues. So they try to help you read those a little bit better.
As unprocessable due to benefits paid or repaid for TY 2007.
Okay, I think someone's got a microphone. I was just listening to see if you had a question. So if you are having a conversation, just be sure you mute so you can talk to the person next to you. Cation exchange capacity. So this is the attraction of nutrients onto the clay or organic matter in your soil. So calcium has a positive charge and clay has a negative charge, so they're going to want to hold really tight together. And potassium has a positive charge and organic matter has a negative charge. So if you have a high cation exchange capacity, it's going to really want to hold on to that calcium and potassium. And likes repel. So nitrate is actually a negative ion, and so is clay. So your soils aren't going to be able to hold on to nitrate very easily. So that's why it's so soluble in soil and why it just goes down to the bottom of the profile. Clay and phosphate. Phosphate is a negative charge. So there's some nutrients that are going to hold onto the soil really tightly and stay there, and there's others that are going to get washed away a little bit easier. So different soils have different cation exchange capacities. It's related to your soil texture. So soil textures that have a lot of clay have a high cation exchange capacity. And cation just stands for that positive charge. Anion would be a negative charge. So CEC loosely means the capacity of your soil to hold on to nutrients. So on your soil test, this is one thing they're going to give you. So this one says the texture is alone, and the cation exchange capacity is 16. Now the percent base saturation is an estimate of how many of the total little places that nutrients can hold on to are filled up in your soil. So the 127 would be kind of high. And then it shows what is holding on to the soil. So this one says calcium is a pretty high percentage of the CEC. Magnesium is pretty low. Potassium's about average, and sodium's a little bit high. So they're just saying, you know, what's holding on to the clay particles in your soil. Then they look at some ratios. So your calcium to magnesium ratio and your calcium to phosphorus ratio. Their recommendations are to watch your magnesium and watch your phosphorus. So sometimes calcium can compete for cation exchange places on the soil. So it can be harder to get your magnesium and your phosphorus, or manganese and phosphorus to stay in the soil and be available. So that's kind of a complicated thing there. So here it shows the NO3 parts per million and the NH4 parts per million at the 1 foot level. And most of the soil tests we do for gardening and landscape are going to be just the top 12 inches. And so they're saying you've got 20 parts per million of nitrate and 3 parts per million of ammonium. So the total would be 23. And for whatever crop you told the soil test that you wanted a recommendation for, they're saying that you need 69 pounds of nitrogen per acre, and you've only got 23 there. So that's kind of a little fertilizer recommendation in the corner. And we're going to look at how we actually calculate this on our own. To give these fertilizer suggestions, you have to provide them a planned crop, a planned yield for that crop, any compost or fertilizer additions that you've added there. So that's usually more information than we have, or we're testing general areas like a raised garden bed where you're going to grow 10 different crops and you had 10 different things in there the year before. So it's usually best if we just figure out our own fertilizer recommendations. If you're a large farmer, this is very handy. They have a lot of data. Usually they will have a category called garden or ornamentals and just give you one number for everything, which sometimes is not the most helpful. So we're going to use CIS 1182. That's a bulletin by the university. It's called Using Soil Test Results for Garden Fertilization. And the email I sent about 4 o'clock today, I included that as an attachment on the email. It's also available online. Oh, and I forgot to send you the example soil test in the email. So I've got screenshots of it on here. We'll kind of walk through using that. And we're going to look at, by reading that soil test and reading the recommendations, how much fertilizer we'll have to put on the garden. So you guys will be all prepared to do those calculations once you have your soil test results. And we have 6 minutes to do that in. So we're going to move kind of fast here. But it's pretty easy. So if we looked at our soil test, let's say it had a nitrate nitrogen of 5.7 parts per million and an organic matter of 3.6. So we were working really hard on our organic matter. So there's this little table in that CIS, and it says your soil test nitrate on the 1 column. So ours is only 5.7, so we'd be in that less than 10 category. And then it wants to know if we're doing a lawn, tree shrubs and perennials, or vegetable gardens. So let's kind of compare. And our organic matter was high, so we want to be in that far column that's greater than 3% organic matter. So they're saying our lawn needs 3 pounds of nitrogen per 1,000 square feet. Our tree shrubs and perennials would need 1 pound of nitrogen, and our vegetable garden would need 2 pounds of nitrogen. So these are still pretty general guidelines. There's a lot of things that could be under the shrub and perennial category, and a vegetable garden can consist anything from rhubarb to spinach to strawberries, but these are just some general numbers that they're looking at. So your lawn is generally going to need more than any of those 2 categories. Your vegetable gardens being next, and your established tree, shrubs, and perennials even lower. So if we look, if our soil test was over 60 parts per million, then I'd recommend that we didn't put any nitrogen fertilizer on there. So that's kind of how these tables work. So now we can look at providing that nitrogen. And one of the challenges is it's really hard to provide nitrogen in an organic form because most of the organic forms aren't very concentrated in nitrogen. So we are supposed to apply 3 pounds of nitrogen to our lawn. And if we can look here, our average application rates for the analysis. So alfalfa meal is probably one of the higher nitrogens, that and blood meal, to get an organic source of nitrogen. So we can put 6 pounds per 1,100 square feet or 4 pounds per 100 square feet, and that's fairly reasonable. But if we look down to like compost commercial, its analysis is it's only about 1% nitrogen and 1% phosphorus, 1% potassium. So you need to put 270 pounds of that on per 100 square feet. Well, that gets a little thick for turf grass, so that can be hard to meet the requirements. So compost works really good. If you can see, its primary benefit is organic matter. It can be really hard to get your nitrogen from just the compost. So if there's anything that you want to, even if you're trying to grow organically, that you want to cheat on, probably chemical fertilizer when it comes to nitrogen may be something you have to look at for doing that. So let's see if we're using inorganic fertilizers. They give us this nice little calculation. So you get your recommended nitrogen rate from table 1. So that was the table we were just looking at that said the 3 and the 1 and the 2. The square feet of the area to which fertilizer will be applied. So, either measure your garden bed or measure your lawn. And then the first number on the fertilizer bag goes on the bottom, times 10, and then this is the pounds of fertilizer you needed is your answer. Okay, so let's say we needed 3 pounds of nitrogen for our lawn. And let's make this easy and say that our lawn was 1,000 square feet. And then let's pick a common fertilizer here. Oh, I'll pick one that's high in nitrogen here. So let's use that ammonium sulfate, kind of like the poor guy did that applied a little too much. I should have taught him this calculation. So that ammonium sulfate was 2100. So I'm going to put the 21 in the denominator, and then it says times 10. So 3 times 1,000 on top is going to be 3,000, and 21 times 10 is going to be 210. So if we got 3,000 divided by 210, let me whip out the calculator on the phone real quick here because it's too late in the day to do that in my head. The 3,000 divided by 210, I want to put 14.3 pounds of fertilizer on that lawn. So that's how those numbers work. So if I picked a 10-10-10 fertilizer, then I'd have to apply more than I did with my 2100 fertilizer. As I said, the guy that used it, I think it was a 50-pound bag that he had in the back of his car, and he'd used most of it. And I don't know if he had 1,000 square foot lawn, so he had definitely over-applied. Okay, so here's what it looks like for phosphorus. Let's say we had a soil test that had 25 parts per million and 9% lime. So we go down the left-hand side, and we're looking for 25, so we're going to be in that third one down. And we're going to be 9% lime. As you can kind of see, the trend is if it has more lime, you're going to have to need a little bit more phosphorus fertilizer. So if we look in that 8-12 on the percent lime and across on that 20-30, our lawn's going to need 1 pound per 1,000 square feet. Our tree shrubs and perennials are going to need 1 pound. And our vegetable gardens are going to need 2. So this works a little different than nitrogen because the lawn needed all the nitrogen. Well, the lawn isn't really supposed to bloom or produce fruit. So that's why your vegetable garden has twice the need of phosphorus that your lawn or your trees and shrubs do. So phosphorus can be a little easier to provide, and you probably can do this organically just as easy. So high phosphorus bone meal is really high in phosphorus. And these tables comes out of the Planting the Idaho Vegetable Garden book, and this table goes down a lot lower. So you would look for an organic amendment that had a lot of phosphorus in it. And now here's the hard part with inorganic fertilizer. So if we put ammonium sulfate in, we didn't get any phosphorus. So you kind of want to go up there and find one, and we still want one that's going to have a little more nitrogen than phosphorus in it if we're putting it on our lawn. But maybe we want the other way around if we're putting it in our garden. So then to find those numbers that work out for what you need to apply. And that can be the real challenge is if you're trying to balance all 3. So I usually try to go with nitrogen first and get that one balanced. And then if I know I need a little bit of phosphorus, pick one that has a moderate number as that second number. And we generally, as I said, I've never seen a soil in our area that needed potassium, but maybe if you're dealing with a potting soil or brought-in soil, that might be something. So the potassium table's very straightforward. There's not 2 little different things you have to look on. So let's say the potassium test was 375, would be in that last category. And it says only your lawn would need any potassium added. And I don't know, and none of these on the organic fertilizers are showing very much potassium. But you can see on the inorganic fertilizers, your potassium would be that last number, and there's several sources there. Okay, so I made it through the PowerPoint, and it's 6:32. I didn't do too bad. We had to go fast on a few spots there. Anyone have questions for me? And you can either use the chat box or your microphone, whatever one works for you. Anybody? Everybody's quiet tonight? Once again, you know, I blab for an hour long. I don't leave you much opportunity to think of questions. Okay, so our next Tuesday at the same time, we'll be meeting again. I'm trying to decide what topic we're going with next. I've actually opened it up to my colleagues to maybe have a hand at coming teaching you on Zoom. So if one of those step up for next week, we'll do whatever topic they want to do. Otherwise, we'll probably kind of continue on the soils line and probably look at different types of composting, because that's a logical next step on what we've been learning here. And then our next in-person meeting for my Jim County people is March 9th. So March 9th from noon to 6, I will get to see everybody again, and we will bring soil samples that day and do more with soils and composting. We're even talking about maybe going out to Jan's house to have her help us build a compost pile. So,
Well, mine's built, but we can turn it.
Yeah, or to get it turned. So that'll be good to see it in action.
Right.
Okay, with that said, I've got actually I went and bought the birthday cake, so I don't have a birthday cake to make, but I do have a house to clean before my mother-in-law comes over to have birthday cake with us. So that's where I am headed next. Okay, so have a great evening. I will get this posted. It'll probably be later afternoon tomorrow. As I said, I'm traveling to Coeur d'Alene. And I will get last week's fixed, so you'll be able to see last week's too.
Okay, thank you.
Thank you. See you guys later.
Okay, bye.